Number 44. Let sigma of a sub n be a series with non-zero terms. The ratio test for determining the convergence or divergence of the series fails with the limit as n approaches infinity of a sub n plus 1 divided by a sub n is equal to what? So pretty much what this means is that if you have a series and towards the very, very end of the series, and I know there's not really an end, it goes on forever and ever, but as you get further and further along the series, the ratio of the next term to the current term, so for example, let's say our series was just dividing by 2 over and over again. So let's say a sub n was equal to 1/2 to the nth power. So that would mean that you would have, so a sub 1 would be 1/2, and then a sub 2 would be 1/4, and then a sub 3 would be 1/8, and then dot, dot, dot. So eventually, these numbers are going to get really, really small, and so at the very end, and like I said, not really an n, but just an n that we're deciding, it's going to be 1 over 2 to the n, and then 1 over 2 to the n plus 1. So what the ratio test says is that if you take the limit as n approaches infinity of the absolute value of a sub n plus 1, so in this case 1 over 2 to the n plus 1, over a sub n, or in this case 1 over 2 to the n, and this value is equal to 1, then we don't know what happens. We have to use some other kind of test. And that's actually what this says. The convergence or divergence of the series fails. When it's equal to 1, it fails. But let's say this was less than 1. If this is less than 1, then we know that it converges. If it's greater than 1, then we know that it diverges. But if it's equal to 1, then we don't know, and we have to use some other kind of test. So just for the sake of this, let's see if this one converges, diverges, or if you're going to need to figure something else out. So this will be the limit as n approaches infinity. And let's just take the reciprocal of the top and bottom. So, rather, if you're dividing by 1 over 2 to the n, that's really the same thing as just multiplying by 2 to the n. So this is going to turn to 2 to the n over 2 to the n plus 1. So then if we evaluate this, that'll be the limit as n approaches infinity. And then if you have 2 to the n divided by 2 to the n plus 1, well, let's see, that's just going to be 1/2. So no matter what n is, this is always going to be equal to 1/2, and that's less than 1, and so we know that this sum is going to converge. The sum of all of these terms is going to converge. So it's less than 1, so we know it converges. If it's greater than 1, it's going to diverge, and if it's equal to 1, which is what this question is asking for, then we don't know what's going on. We have to use some other kind of test. Alright, so if you have any questions from other tests, make sure to leave a comment, and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.